everyone and welcome back to the channel. Now in this video we're going to look at the WINSPACE Hyper Rim Wheelset in 50mm. As a precursor or a bit of a prologue to this video, go and check out the review I did of the disc Hypers in the same depth, 50mm. Now in that video, which I posted online maybe about a year ago now, I went really in depth into the hub design, the spoke pattern, the spoke geometry, the spoke materials, and we did a very in-depth kind of lateral stiffness test on the test bench versus other off-the-shelf wheels and wheels that I've built with, normal hubs and normal CX-ray spokes. And we found in that video that the WINSPACE, although being very light, are exceptionally stiff out of plane. So the lateral stiffness test showed them to be way stiff. I'll put in the results up here or up here somewhere for you to recap if you don't want to watch that video. And having spoken with Raoul from Lucia Technic, he did a similar lateral stiffness test and found pretty much exactly the same result. So they're right up there in terms of lightweight Meilenstein's lateral stiffness. Now, before we get into the massive content of this video, I'm not going to repeat that test because the rear wheel in particular has pretty much the same spoke layout as the disc brake version. The front wheel doesn't, but we can approximate a little bit, so I'm not going to go into that. And there's a few other legacy issues and actually things that we need to discuss that have arisen since testing these further and riding the rim brake ones as well. So in that video I mentioned that it was quite endearing and engaging of WINSPACE, really a small kind of carbon frame and wheel brand, to engage with like engineering or cycling YouTubers and be open to critical analysis. And I told them at the time, as you'll see in the last video, I wouldn't hold back on my analysis, I wouldn't hold back on my feedback, and I would make it public to you. And they were okay with that, which I thought was pretty cool. And I would say for about a year now, I've had a bit of like a kind of technical partnership with WINSPACE, and we've been developing and testing different axle types for these hubs. We've been testing different ratchet rings for the hubs and different geometries of ratchet rings and doing stuff like that. So it's been quite cool to be involved in that technical partnership with WINSPACE. And this brings me on to the next subject, full disclosure. WINSPACE sent me these wheels for free. I didn't pay for them, the rim brake wheels to test. And they've continued my discount code, which I set out in the last video. And I said in the last video, you don't have to use them, the discount code, you don't have to buy the wheels. As long as our technical partnership is still valid and they certainly see my feedback as beneficial, then they'll continue to offer that discount code. So I'll put that here, and it's also in the description below if you want. If you're reading a wheel review and it says, or you're watching a wheel review and it says like, oh, these wheels spin up well or they hold their speed, then they just move on, because all wheels spin up well and hold speed. They've got small bearing in the middle, quite low inertia if they're a carbon wheel, and most of the weight's at the outside, so of course they are. So first topic to address then is the stiffness, and like I said, the results, I won't be repeating that bench test that I did with the disc brake wheel set, because the rear wheel on the WINSPACE has a same spoke pattern on dry side and non-dry side. So you've got radial on the non-dry side and 2-cross on the dry side, same number of spokes, so the stiffness test and the rim is exactly the same, so the stiffness should be more or less the same. And we deduced in that video that the increase in stiffness is to do with the spoke material. They are considerably stiffer in tension than a normal CX ray or wire spoke. So I'm not going to repeat that test. The front I can approximate as being around the same stiffness as the disc brake front wheel. Yes, it's only got 16 spokes, not 21, but because of the radial spoke lacing and not having the disc brake in the way, the bracing angle on the front wheel is much wider than it would be on the disc brake wheel. So that's going to bring some of the lateral stiffness component back in favour of the rim brake wheel, although it's got less spokes. So moving on, let's talk about the spokes. Like I said, 16 on the front, 21 on the rear. Let's talk a bit more about the spokes construction, and forgive me, I'm using my crib sheet here because there's quite a lot to get through. So the spoke construction I spoke about in the, excuse the pun, I spoke about in the last video, and my concern with these kind of novel carbon spokes at the time was that how is the aluminium insert attached to the UD carbon? And I didn't really look at them that closely last time, and I assumed that the aluminium threaded end and the aluminium kind of other end, the straight pull end, I assumed they were kind of bonded on with epoxy in like a cylindrical sleeve joint. And we were discussing in the comments on the last video about how we thought the failure mode might be basically the shear strength of that bonded joint. And I thought, well, you're never going to snap down the middle of the carbon because that amount of UD carbon is extremely strong in tension. And actually it's a really nice use for UD carbon fibre because spokes are pretty much always in uniform tension. They can't react to any bending loads, they're too thin, and they don't really see compression. Well, they see relative compression, but they're still always in tension. So to use UD carbon for a spoke material, or like anything like in just pure tension, is a really nice application of carbon. but I was always worried about the ends. And since doing a bit more investigation into these spokes, they've actually done some clever design, and it's the same as on the previous wheel sets. They've always been like this. The ends are kind of mechanically locked into the spoke with a taper. So the aluminium parts have a kind of conical female taper, and then before the spoke is formed and has its bladed shape moulded in, they're slid onto the spoke, I assume, and then the ends of the spoke are flared out with the matching male taper. So when the thing is cured, and the epoxy is cured, and I'll draw a little graphic of this and put it on the screen somewhere, the aluminium ends are basically mechanically locked on those tapers, and they can't come off either end of the spoke in tension. So that's a really nice bit of design. It's quite neat, it works. Once the thing's set, you can't get the ends off, they'll never pull off. You don't need to worry about that glue joint, that sleeve shear joint of glue that I was worried about. They're basically mechanically locked on, and once the carbon UD and epoxy is cured, they ain't coming off. So as long as you look after the threads and you don't strip the threads on the end, these should last a fair while. Now, that extra processing is why these wheels are quite expensive, because to do that is more tricky in production, and it's a lower volume thing at the moment than producing CX-ray wire spokes, which are basically stamped, bent if they're J-bend, and then a thread is rolled onto the end. This is a little bit more nuanced. You've got to machine the aluminium ends, there's a bit of processing to do, there's a mould for the carbon to get the bladed profile. So yeah, it's a bit more nuanced. Now, going back to the spokes, another thing I found with these is they do have a kind of small serial number on them, marked ST01. And having looked at some other carbon spoked wheels like the Hunts and the new Fast Sports ones which are coming with carbon spokes, they also have that same ST01 mark on them in exactly the same place. So I think these are all coming out of the same factory, which in my eyes is good, because it means that factory has got more responsibility to the market. It's got more spokes in the market, it's got more reputation on the line, so it's probably done the R&D properly. I'd much rather these all come from one factory than all the different carbon factories kind of cherry picking from the cheapest supplier, like is the way in other parts of the bike industry, let's say. So that's a good point. They seem to be working. I haven't failed any of these on the disc brake wheel set, and I've done thousands of kilometers on these disc brake wheel set now, and not had a single problem with them on the rim brake wheel set. There are a couple of problems in the market which we'll address, because I did do a Q&A on the community feed about these wheels, and some people did highlight some problems, so be patient, we'll come to that at the end of the video. And I would say, actually, from my experience, like, I like to build wheels. I've built pretty much all the wheels that I ride on my road bikes, and I always use Sapim CX-Ray. And I would say, when people are getting into wheel building, apart from the bearing layout and preload reliability of the hub, the spokes are probably the most overlooked part of a wheel set. If you're going to spend your money on one part of the wheel set, I would say get decent spokes. So CX-Ray all the time. And as I always build with Sapim CX-Ray, going to something with a novel, almost proprietary spoke, I was a bit nervous about that, but these have stood up to the test of time. As you can see in some of this like B-roll footage here, I'm quite a big rider, and I've been absolutely thrashing these to try and break them. Now, some might say if I'd spent my own $1,100 on these wheels, I might be a bit more kind to them. And yeah, full disclosure, I did get these for free to test. That kind of gives me like free reign and liberty to absolutely thrash the pants off them, because I'm not protecting my investment. You can see here, like, we went and found a 20% gradient and stuck it in the small big, which is the highest torque combo for the max stress on the wheels, or the rear wheel, and spanked up the hill as hard as I could do for sort of 5-10 seconds to try and get any creaking out the wheel. Just like the disc brake versions, the hubs are a pretty trick 5-axis CNC machining. They're extremely lightweight, and they are custom made for these carbon spokes, so you can't use these hubs with, to my knowledge, any straight pull spokes. They are proprietary for the custom carbon spoke head, which is nice because they've actually had to design something, you know, with their own engineers, rather than just cherry pick a hub off the shelf like so many other companies do. Will go and buy just a Chris King or an Envy and lace it to their own carbon wheel. So they've done, you know, the hard work. They've done some proper engineering to make the hubs good. The tolerances are good. The preload system works. The preload system is what I call preload by displacement. So that's finely toleranced bearing seat widths with finely toleranced shoulders on the axle, and then when everything is clamped up in the dropouts, all the axial clearances and the bearings get taken out and a slight preload is added, and that's actually very hard to do. A lot easier method to do it is to do it like White Industries on Mavic, to use a threaded collar or some sort of like sliding collar like White Industries use. and that's kind of like an infinite preload thing, just like the non-drive side Shimano crank arm. That's like a threaded collar you can apply a certain amount of preload with. It's easy, but it's not the most elegant solution. It requires a few more parts. If you can do it like this, which is like how DT Swiss also use it in their hubs, what I call preload by displacement, where everything is like matched lengths to take out axial clearances. You need to get down to kind of like 10-20 microns in the machining to achieve that properly without binding up the bearings or not having enough preload. But if you can get it to work, it's the most elegant solution. So kudos to WINSPACE for doing that. Seems to be pretty good on all the wheels I've tested from them. And for ease of maintenance on the hubs, and I'll show you this on the rear as well, they've got push-on end caps. So to get at the bearings, to check the grease and stuff, check the the state of the bearings, you just pull the end caps off. Sometimes might require sticking it in a little vise with some rubber jaws on it, or some rubber jaws around the pair of pliers to get the end caps off. But ease of maintenance wise, you can pretty much strip these down without the tools. To get the bearings out, yeah, you need a drift and a hammer, but get the end caps off, they just pull off. Now that adds some complexity, which we'll come on to later when we start talking about legacy issues. Now in the disc brake video, we didn't actually dwell too much on the rim itself because there's so much going on with the disc brake wheel. The most important thing for me is hubs and spoke pattern to deal with the braking forces. You're not putting the heat into the brake track at the rim, and as long as it's moderately aerodynamic and light and strong enough, it's not going to explode. That's all that matters. Now with the rim brake wheel set, obviously the brake track becomes very important, but aesthetically they're very similar to the disc brake ones, and they've got this wonderful kind of butterfly woven effect, which is filament wound, and yeah, the Aero profile is pretty much the same as the disc brake one. They are not the widest in the market. I would now say maybe 5 or 6 years ago they would be considered as a wide wheel. Now they're kind of somewhere in the middle of the internal width. So the internal width is 19. I think the widest point on the outside are about 26. Now that's considered narrow by some brands now. Some brands are going like 22mm internal. From my point of view, I think that's a bit too wide. I'm not a massive fan of the wider wheel. I think 19mm for me, if you're running 25mm on a lightweight race bike, or a TT bike for that instance, is about optimum 19mm. It gives a 25mm tyre a very nice profile, and actually on here, just to give you a guide, this is a 28mm GP 5000. Now the 5000s are a bit narrower than the equivalent 4000s used to be. So this would be like an old 25mm 4000, and for some reason Conti made them a bit narrower when they did the new mould for the 5000. But you can see even that 28mm 5000, which measures about 27 true, as a really nice transition to the brake track. Now braking, how do these wheels fare in braking? Now obviously I've mentioned this on this channel before. I'm not a massive advocate of using carbon clinchers if you're really heavy and you live in a hot place and you do very long downhills. The TG, or the glass transition temperature of the resin, is always going to be in the back of your head. So anything really hilly and really hot, I'll always use the disc bike. If it's flat or rolling, or pretty much anywhere in the UK, rim brakes are absolutely fine for me. And out of all the bikes I ride the rim brake one the most. So how do these fare in braking? They're okay. They're not the best. So I've tried them with my own carbon brake pads, the ones that you can get from CRC and Wiggle. I've tried them with the brake pads they're supplied with, and yeah, they work best with the brake pads they're supplied with. That's no surprise. But due to the rim surface being so smooth, there's no textured brake track. In the wet, they aren't the best. It takes a good few revolutions for them to clear the water. The other modern carbon clinchers like the Zips and whatever, some of them, even the lower end wheels now have got textured brake track. I still think they bite a bit better in the wet. In the dry, these are fine. It takes a bit of time to transfer some pad material onto the rim brake surface, I found, when they were brand new, but they need a little bit of bedding in. I told you there was a lot to get through. A little bit of point of contention for me is bearings. Now, just like the disc brake wheels, these come supplied with a bearing called S&S. Now, obviously you've got 4 bearings in the rear hub, 2 in the front. The good thing about all the WINSPACE hubs is the axle size is big. It's a 17mm axle, so you're always going to get quite a decent static load rating out the bearings because they tend to be quite big bearings. If your bearings have a very small axle and a very small bearing, you might eke out a couple of tenths of a watt in rolling resistance, but the load rating goes down massively, so the life of the bearing goes down massively. So it's always better to have a bigger axle, and it just makes for a stiffer hub as well, and the bearings are going to have a longer life, which is good from my point of view. I can sacrifice 1/10 of a watt for a bigger bearing and have it last longer. That's a good design feature. But these S&S bearings, they seem to be from Taiwan, or they have like a factory in Thailand and China. I don't really know where they're coming from. They're hybrid ceramics, so they've got, I believe, stainless steel races with ceramic balls. I still don't really think the ceramic thing, I think, to be honest, the WINSPACE, I think they could drop the ceramic thing, right? I think people are over the ceramic bearings for bikes now. Ceramic bearings, in my experience, in like professional engineering, tend to be for very high temperature or very high speed applications. None of those are related to bicycles, so why are we using them? It's a marketing gimmick that I think ceramic speed poisons cycling with, and I think we need to do away with it. But yeah, what I would really like is one bicycle wheel manufacturer to come out and say, here's a wheel set, or here's a hub with SKF bearings in it. Here's 4 SKF or 2 NTN bearings in it, with proper seals, with proper preload arrangement, proper tolerances. And yeah, the carbon spokes work great, and they do offer a very unique ride feel to this bike. They're very stiff, and when you're descending on a smooth road, you can feel the extra stiffness. But I would forego having carbon spokes. I would like to have a normal spoke with really good quality bearings as standard. Now, I don't know any hub manufacturer, even maybe Chris King, that will supply a really high quality bearing like an SKF or an NTN as standard. And I would rather sacrifice maybe the carbon spokes for a normal steel spoke to get that as standard. Now, the companies don't do it because that caliber of bearings is super expensive, right? It might cost, to do a wheel set, like €100 to get those bearings in there, and that's a big part of the profit margin for the manufacturer gone. But I think the market is wisening up to bearing choice now, so it would be really nice to have a really good set of bearings in there. But that's just my personal preference. So far, these bearings have lasted okay. I've not had any problems with them, but I don't foresee them lasting as long as a really good quality bearing. When I pulled the end caps off when the hubs were brand new, I would have liked to have seen just a bit more grease in there. Obviously, the grease is inside the seals in the bearing anyway, but it would be nice to see a bit more grease in there just for overall weatherproofing. And yeah, I can sacrifice 1/10 of a watt in rolling resistance, just to add a bit more weatherproofing and keep the hubs quiet for a bit longer, especially the axles, which we'll come on to. Freehub is very good quality. It's machined from 7075 T6 aluminium, which is quite hard aluminium alloy. It's amazing how many Freehubs on the market that are still machined from 6061, which is basically like cheese and very soft, and that gets bitten by the cassette very easily. Now, obviously, you can alleviate biting as much as possible if you do the cassette up to 40 Newton meters, which most people don't. Most people don't have a breaker bar or a torque wrench big enough to apply 40 Newton meters. But if you do your cassette up to 40 Newton meters, you don't need a bike guard. I'm telling you now, torque them up properly. And yeah, you can see here, here's a Dura Ace hub. That has a titanium Freehub. This is a wheel I built with the Dura Ace hub. It doesn't need that titanium Freehub. I'd rather have an aluminium Freehub on there to save weight, because I know I can torque up and I can get the cassette, the inside face of the cassette, against the right at the base of the Freehub. You can get quite a lot of torque transfer through that friction contact if you really torqued it on tight, and then the biting becomes less of a problem. But anyway, make sure you do your cassettes up to the rated torque. Can't remember what it is, about 40, and you shouldn't have a problem. Quick releases. Put the quick release through it's a fairly standard quick release. It's like an enclosed can, which is nice. It's not an external cup that's going to get full up with grit and salt and stuff. So I put them through the little quick release testing device that I made before, and I've shown that in other videos. And yeah, they're pretty good. They're pretty high, about 370 kilos, I think the front one was. Moderately tough closing force with a hand. And the head of the quick release is a glass or carbon filled like nylon plastic, which is a little bit, nice to see that in aluminium, but it seems to work. And the handle is a nice hard anodized aluminium. So if you want to see the other results from the other quick release tests, I tested a couple of different quick releases. These are, I think, much better than the kind of lightweight titanium little kebab skewers, and they're much better than the prime quick releases that I tested, which come with like your prime carbon clinchers from Wiggle and CRC. So these are pretty good in terms of actual compression load. And I've gone through this ad infinitum. Load paths from wheel inputs to hubs to frame don't go through the quick release. The quick release skewer or the through axle, even if you've got through axles, aren't designed to take sheer vertical loads, right? They're really only there to provide compression to the hub, to set up those high friction interfaces between dropout, end cap, axle and bearing. That is the load path. The quick release skewer, or the bolt through axle, isn't designed to take shear loading. Now it does take a bit of, like in a disc brake application, it does take a bit of like twisting, bracing from the asymmetric disc brake forces, but they should never be designed to take radial loads. Now why am I saying this? Well, you're relying on compression to make the load path go through the dropout to the end cap, to the axle, and then to the bearing, so the hub can do its work properly, and then through the spokes to the tyre. That's the load path you want. So having a quick release that can provide a high enough clamping load, or a through axle that can provide 12 Newton meters of clamping load, is essential. And why do I say that? Well, people have complained about these wheels having an issue of creaking, right? And some people complain that the end caps seem to creak on the axle, and it's largely solved by making sure your quick releases are done up tight enough, or done up really hard, because like I said, these are push on end caps. You're relying on a friction contact between the end cap and the axle to transfer that load. If that friction isn't high enough because you haven't clamped it up enough, you're going to get some kind of stick slip behaviour in there. Now some people have reported on the rear wheel, at least, I know this is the disc wheel, but it's the same arrangement on the drive side. Some people have reported creaking from where the two spokes cross. That is possible. I've never experienced it on mine. Carbon on carbon, they will cross, and carbon on carbon is, to my knowledge, a much higher friction coefficient than steel on steel. Now if you look at a two-crossed steel wheel, they always rub, but you just don't hear them. But if you look at the anodizing or the paint on a steel, or the black oxide on a steel spoke, you'll see how it's rubbed off by the cross. So they will rub. I've never heard it audibly, and you can see, like in the B-roll, like I mentioned earlier, when we're smashing it up. Now don't forget, torque is power divided by speed. So if you slow down the wheel RPM, i.e. on a very steep climb, and you put the bike in its lowest gear, and you have a very high power, like you do your sprint power, like 1200, 1500 watts, then that torque, it's just a physical relationship, is the highest torque you can put into the back wheel. So if you're going to test creaking spokes, or creaking dropouts, or creaking end caps, that's why we went to this 20% wall. Put it in small and big, and then give it your full sprint power, and that's going to put the hardest torque on the rear wheel. If you're going to hear any creaking, you're going to hear it in that situation. And you'll know what I'm talking about when you're really suffering up a steep climb and you're really putting the power down. Sometimes on any wheel with metallic spokes, you can hear kind of like a whirring or a pinging noise as the spokes kind of really do their work. Now, I've never had any creaking from these wheels because I always do the through axles up tight and the QRs up tight, and I just can't hear the spokes creaking. Some, maybe the spokes do creak because the surface is a little bit different, but if you do get any creaking, your through axles are still tight, on the rear wheel, just add a little bit of grease right on the, so pull off the end caps, add a little bit of grease right to the end of the axle, put them back on. Don't add grease to the dropouts themselves, because where they go on the frame, you want that very high friction, you don't want that grease, and then just do them up as hard as you can. Not as hard as you can, but do up the QRs tight and do the through axles to 12 Nm, and you shouldn't have a problem. If you do, report back here, I'll be interested to know. Someone else mentioned in the little Q&A that I did, I've had detensioning spokes on the non-dry side on the rear wheel. Now, they reckon that's from the radial spokes being next to the disc brake, and the torsional braking forces then have to travel through to the trailing spokes on the other side, so the tangential spokes on the other side have to do the braking because these are all radial, they can't take any torque, and they are wondering that these are becoming detension. Now, I've never had that problem. Like I said, I'm 88, 90 kilos, and I've got a 160mm rotor on the back, and this rear wheel is still true. I would say just retension the wheel and maybe add Loctite to the spoke nipples and just see if it happens again. I don't believe that's a widespread problem, but I might be wrong. If it's likely to happen, it's probably more likely to happen on the front wheel because most of the braking load goes onto the front wheel, so the torque's going to be a bit higher. But then again, on the front wheel on the disc brake bike, the spokes next to the disc are tangential, so they don't have to go through the hub to find the load path to the wheel. Whereas on this side, I did comment this on the last video, that it is a bit odd to have these radial spokes next to the disc brake. And like when I'm building any rear wheel, I'd always put 2-cross on the back, whether it's rim brake, both sides, or disc brake, because I just want more spokes doing the torque transfer from acceleration and braking. But that's what WINSPACE have gone with. It seems to work for me at least. I've not had any problems with these wheels, they're still true. And the rim brake ones, again, are pretty much the same, can't fault them. So, very long-winded discussion on the WINSPACE Hyper Rims. I hope that's cleared up any issues or questions you may have had. If I've missed anything in that Q&A section on the community tab, put them down below. Hope you enjoyed that. Stay tuned for more. I'll do another update on the rim brake wheel set when I've done as many cases as I have done on these ones, and fingers crossed they're all going to be all good. So cheers, and see you in the next one.